In section 5.3.31, according to a poll, about 11% of adults in the country bet on professional sports. Data indicates that 52.8% of the adult population in this country is male. Now we want to be able to complete parts A through E. Now the first question is asking, are the events male and bet on professional sports mutually exclusive? We want to explain that. Well, again, what does mutually exclusive mean? Well, it's events that have no outcomes in common. A person can be both male and bet on professional sports at the same time. Therefore, the events are not mutually exclusive. Now, assuming that betting is independent of gender, we want to compute the probability that an adult from this country selected at random is a male and bets on professional sports. Now again, going back to the definition of independent events, the probability of event E and F can be found by using the formula. The probability of event E and F is equal to the probability of event E times the probability of event F. And so we're going to determine the probability of events is male and bets on professional sports. Well, what is the probability that the person is male? Well, from our question, it states that 52.8% of the adult population in this country is male. So therefore, converting that to a decimal is 0.528. And then the probability that person bets on professional sports is 0.11, which is 11%. Now what we want to do is we want to calculate the probability of being a male and bets on professional sports. Now, because this is and, we're going to multiply the probability of being a male times the probability of bets on professional sports. So 0.528 times 0.11 is equal to 0.0581. And therefore, the probability that it's male and it bets on professional sports is 0.0581, or if you convert that to a percent, moving the decimal over twice, is 5.81%. Assuming that the events are independent. Because if it's independent, that allows us to be able to multiply. Now we want to use the results in part B. We want to compute the probability that an adult from this country selected at random is male or bets on professional sports. So since we're talking about the key word, which is or, then we have to use this formula for or. And if the two events are not disjoint, we're going to use the general addition rule. So for any two events, E and F, the probability of E or F can be found using this formula. Now recall that the probability of male is 0.528, the probability that bets on professional sports is 0.11, and then from what we found in part B, probability of male and bets on professional sports is 0.0581. And then what we'll do is we'll take these values and then plug them in to this particular formula. So we're going to take the probability of the male or bets on professional sports is equal to the probability of the male plus the probability that it's bets on professional sports minus the probability of male, and then I'm going to abbreviate this, and bets on professional sports. And so now using that formula, we're going to take 0.528 plus 0.11 minus 0.0581, which gives us the results of 0.5799. So therefore, when we talk about the OR statement, it would be approximately 0.5799 or 57.99%, again, assuming that these events are independent. Now in part D, the poll data indicated that 7.5% of adults in this country are males and bet on professional sports. What does this indicate about the assumption in Part B? Well, what it's saying is, what is the probability that male and bets on professional sports according to the poll? Well, the probability that it's male and it bets on professional sports is 0.075 from this question. Notice that this is not equal to the value found in Part B. Because the poll determined a different value for the probability that an adult is male and bets on professional sports that was found in Part B when the events were assumed to be independent. The assumption was incorrect and the events are not independent. And so this last question states the following. It says, how will the information in Part D affect the probability that you computed in Part C? Well, because the events are not independent, the value calculated in Part B cannot be used in the calculations for Part C. So we're going to find the probability of male or bets on professional sports. We're going to use the probability that male and bets on professional sports is equal to 0.075 instead of the value that we found in Part B. So the probability of male or bets in professional sports, we're still going to use 0.528 plus 0.11, but now we're subtracting 0.075, which was given in Part D, and now it gives us a probability of 0.5630 or 56.30%.